The topic I will be talking about today is exponential growth. The example problem that I have generated for this assignment is as follows. If Shane has a bank account initially containing $2,500 US, what is the change in his account balance after 7 years while earning an annual interest rate of 2.4% if the account remains untouched? So to solve this problem, we're going to go through a few processes of steps. Our general equation for exponential growth is y equals a times 1 plus b to the power of x. In this equation, y represents our final account balance, a represents the initial amount that we started with, b represents the percent change, or annual interest, and x represents time. In this case, it'll be the number of years that have passed. So our first step is to plug in our information from the problem into this equation. We started off with $2,500, and our interest rate was 2.4%, and it says that we're checking the balance after 7 years. If you calculate this out, you get approximately $2,951.479, which we're going to round to approximately $2,951.48. Now, because the problem asks us for this change in account balance, we have to subtract his initial account balance from the final account balance. So to do this, we take delta y is going to equal y final minus y initial. So we plug in these values, and we calculate this out to find that the difference is approximately $451.48, which means his account increased by this amount. This data can also be represented in a data table where we set up the equation using the elements of the final balance, the initial balance, the annual interest rate, and the time in years, not showing each of the calculations individually. We progress the time in years up by 1 year each, so we can see a representation of each of the 7 years, which, as you can see, does increase exponentially from year to year, which makes sense because this is a problem dealing with exponential growth. As you can see, this graph is a representation of our equation, y equals 2,500 times 1 plus 0.024 raised to the power of x. The x-axis obviously represents the time in years, which are divided by 1 year each. The y-axis represents the account balance in US dollars, and we started those values at $2,500 and ended them at $3,000 because all of the values for each of the 7 years does fall within that range. Because we had to scale the graph to fit in this amount of space, it's not, the exponential growth curve isn't as obviously seen. However, you can tell that the values are correct based on the point plotted, where x equals approximately 5 and y equals approximately 2,814, which is consistent with the values in our data table for 5 years. Alright, so as you can see, exponential growth formulas are really useful in dealing with money, or similarly expanding values such as population or even membership to a social networking website. They're easily calculated in the equation that we talked about, y equals a times 1 plus b raised to the power of x, which represents years. The y represents the final value, a the initial, and b the percent that you're going to change those values by. I hope you enjoyed this presentation.